Good morning, good afternoon, or good evening, depending on where you are in the world. My name is Sharon Florentine. Welcome to today's DevOps.com webinar. We are talking today about the 2021 OSSRA report, Open Source Trends, Risks, and Management, with Tim Mackey, who's a Principal Security Strategist at Synopsys. Before we get started, I need to go through a couple housekeeping items with you. As always, this presentation is being recorded, so if you miss any or all of it, you'll be able to go back and watch it again. We'll be sending an email with instructions for how to access the webinar on demand, or you can always visit us at devops.com/webinars, and it will be there for you as well. Today, we've got a number of handouts for you if you'd like to download those. They're located in the Handouts tab on your webinar console. And we are taking questions throughout the presentation, so you can use the Q&A tab on your console to submit those to Tim at any point. We will try to get to as many as we can at the end of the presentation. So go ahead and send those in whenever you want. At the end of today's presentation, we'll be doing a drawing for $25 Amazon gift cards. So make sure you stick around and see if you're a winner. And with that, I'm going to turn it over to Tim. I'm going to put myself on mute and turn my camera off. Tim, take it away.
Thank you, Sharon, and welcome everyone. So, I advance nicely. Awesome. So our basic agenda today, I'm going to give a little bit of a background for open source. Believe it or not everybody knows what's going on in the land of open source. We're going to cover a little bit about the actual data source that's used in this report. I personally believe strongly in know the data and how the methodology was put together when interpreting the results of a report. So we'll go through that for a little bit. Then we'll do some analysis from the report. Now, I'm not going to regurgitate what's in the PDF ad nauseum. The goal that I have with the webinar is to kind of give you a little bit of a view between the lines, as it were. And then we'll have some conclusions and some actionable bits in here. And so with that as our background, we'll start out with just a little bit of a view into Synopsys and our Cybersecurity Research Center. So Synopsys as a company has been around for like 35-ish years or so. We're in the software integrity or cybersecurity part of the company. And a few years ago, we created a research center whose goal is to promote the innovation that we do, but also to go and perform some hard research based on the trends that we're seeing within our customer base. This OSSRA report is part of that effort. Our core teams are located globally. So we've got teams in Belfast and Boston and Oulu, Finland and Bloomington and a few other places with fewer folks supporting it. But those are some of our bigger locations within the research center. So with that as who we are, what's open source all about? It is actually far, far more than just worrying about, hey, I can freely download this off of GitHub or some other website. Today's modern applications, they're a combination of custom or proprietary code, potentially contracted code, and some quantity of open source components. And as we'll go through the report, you'll find that this is a rather large percentage of the code that's out there today. Then most applications are a little bit more distributed today than they were a few years ago, so APIs are a huge part of that. And then some application behavior and configuration comes in for the ride to give you this modern application. It isn't always just a single executable or a single thing. It can be a full system of applications that have loose coupling to each other and end up behaving as a single thing, even though they are distributed and independently scalable. Now, open source is a way in which software is developed. The OSI has a definition that basically says it's software that can be freely accessed, used, changed, and shared in modified, non-modified form by anyone. It's made by many people, distributed under licenses that comply with the open source definition. Now, the open source definition is something that the OSI maintains. And this is true, but most people think about things just a little bit differently. The common definition that most people have is that it's software whose source code that I have access to outside of a commercial license. It's probably something that is freely downloadable. And importantly, even commercial software has open source components in it. The days are long gone where all software development occurs within the four walls of an organization, which means that managing and securing open source software is a lot more complicated than you might expect. And when you have open source in commercial software, it becomes even more of a problem. Now, there is an important concept in the world of open source, which is the license. You can think of the license as the set of obligations and the rights that are granted to the user of that software when that software somehow is distributed or ships. Now, one of the big problems is that there's no single open source vendor. There is often no vendor at all, but there is still a license. So you need to adhere to the terms of the license. And that whole distribution and shipping piece, that becomes a really interesting problem when you start thinking about things like Docker containers, where the image is pushed to Docker Hub. Well, that was a distribution. So are all of the license obligations associated with all of the things that are inside that container image part of what was communicated to Docker Hub and what is documented with that image? By and large, it isn't. And so that's one of the risks that are out there. Another set of risks are associated with the supply chain that can be present within an open source world. So as a developer, when you want to go and find a component, where you go to find that component and which component that you choose is largely based on the way that you understand the set of requirements. So you might be looking for something that is an email solution. Well, how you did your search might result in a variety of options being presented to you. And each of those types of scenarios can have risks associated with typo squatting or package management, pollution, or any number of other types of attacks that are targeting how open source works or how software development practices work. And the process of adopting open source is also very different than the commercial world. It could be as simple as somebody says, "Ooh, there's something I like, I'm going to download it and I'm going to use it," and have absolutely no process in place around vetting whether that component works other than, yay, it works. The commercial procurement model typically has some form of procurement checklist that is defined by legal and finance more often than not, and occasionally by the security teams, where the component is going to be approved and then put into some repository from which the developers and CI processes and deployment paradigms are going to work. A more mature open source world also has a set of procurement checklists, but it goes through multiple stages where you have a security review that's independent from the compliance side of the equation, where the compliance side of the equation is looking at the license obligations. And then once you end up with the approved component, it too ends up in a repository, and the developer process starts to behave exactly like the commercial library model that I show in the kind of orange area. So that's kind of a basic overview of what the open source world looks like. Now let's take a little bit of a look at the OSSRA data itself. Now, one of the things that's really, really important to understand is that OSSRA data is not a survey of users. It does not have a subjective bias. What it is the result of commercial software audits that are performed whenever there is an M&A transaction. So company A buying company B, and company B's assets are part of that transaction. So every year, billions and billions and hundreds of billions of dollars are spent on acquisitions. Last year, there were 4 times the sales volume or the purchasing volume as in 2009. And in Q3 and Q4 of last year, there were over 1,100 deals. Now, it turns out in Q2, at the height of the uncertainty around the pandemic, there were 3 deals. So it does average out pretty well, but the volume of deals last year was very, very substantial. One part of the Synopsys business is involved in doing the technical due diligence involved in those types of transactions. So an acquirer typically knows who's the strategy behind what their acquisition target is all about. They can assess the people, but when it gets to things like the processes, the tooling, the architecture, the code, they need that third-party audit. That's where we come in. And we look at it from the legal, the security, and the code quality risk side of the equation. The data behind all of this is what we're using in our OSSRA report. So this year, we have a little over 1,500 code bases. So basically the source code for an application that we were auditing. And it's distributed across all of the industries. And one of the important things to remember when comparing this to the world that you work in, if we say that we looked at 10% of our code bases were in financial services and fintech, well, those were acquisitions. So if you see a little bit of a discrepancy between the data that I'm presenting today and what your view of the world is, remember, this is how our data comes to us. So we have an intrinsic bias towards software that is being procured in an M&A transaction, not necessarily something that is an ongoing world. So let's break everything down, kind of look at some of the trends. So first and foremost, we can categorically say that open source powers all aspects of software, end of story. Because if you look at the red highlighted areas, those are the areas where there was a decrease in usage of open source. And I'll just pick on the big data AI and machine learning camp. Last year, there was 100% of the code bases we looked at had at least one component. This year it was 98%. So that's not a very substantial difference. Cybersecurity was probably the biggest one, where it went from 100 to 91%, but that's still within the margin of error for what we have in here. So the net result is code that powers our life today is open source in nature. Now, when we get into the averages of what's going on the spiral side of the slide, over the last 5 years, we've seen the average percentage of code go from 36% to 75%. That's a pretty substantial jump. And we see that jump across all of our industries. So the percentage of code that is open source in nature is quite substantial within all aspects of the modern world. It's part of what fuels innovation, in part because that innovation, that's what's making the applications unique. There's no need to reinvent everything. And it's that foundational element that we get with open source technologies. Now, the license compliance side of the equation is really one risk element that organizations who are using open source technologies need to be aware of. So that we take a look at it in the sense of how many license conflicts are we encountering? So everything that's highlighted in green had a situation where the number of conflicts went down. So there was an improvement in overall license compliance. So that's telecom, retail, IoT, mobile apps, infrastructure services for cloud services, healthcare, fintech, edtech. They all did a better job. Everyone else went in the opposite direction, where there was an increase in the number of license conflicts, and that presents a set of risks to the organization. And chief among those risks are the indeterminate licenses. So these are licenses where there are terms that don't necessarily apply universally. So a perfect example of that is in the US, we have a concept of the public domain. And we can go and have something be placed in the public domain. That license gives free use to organizations that are in the US to go and work with it. It doesn't, however, translate that the US legal concept of a public domain has any bearing in other countries. So if you're using open source technologies and it is licensed to the public domain and you happen to be not in the US, that can present a problem in terms of who has ownership of that code, who owns the copyright, who has the rights to use it, because there is no implicit or explicit right of license granted. Similarly, some components might be freely accessible and downloadable from the internet, but that doesn't mean that there's a license associated with it. And if it doesn't have that license, then there is no grant of use. And so while you might be able to look at things as text on a screen, that doesn't mean that you can bake that code into your product and kind of hope for the best. That's a risk. Similarly, our custom licenses or modifications to licenses that can create conflicts. So that might be adding a commercial clause to an open source license that effectively says, this is open source software unless you want to use it in your business, in which case you need to pay me money. That's a modification or a custom license addition that now creates the potential for conflict within the licensing obligations. And so what we saw last year was that 65% of the code bases had some form of conflict, and 26% of them contained some form of license that effectively was either not licensed or had some customization to it that could be problematic. That presents real problems when you're in an M&A transaction, because do you know the actual code that you're acquiring? And so that can actually impact the valuation of any kind of deal. Now, open source is about responsible reuse. On the bar side of this slide, I've got data from a survey that we conducted last year. So the way that the OSSRA cycle works for us, we do the hard analysis in the spring and early summer, and then towards the end of the year, we conduct a survey that asks some of the questions of DevOps practitioners around things that we observed in this year's data. So last year's survey, one of the questions that we were asking was, what is the criteria that is used to vet an open source component? What's your decision-making process look like before you acquire this? And the reason that we asked it is that we've seen for years that there's a long tail associated with version management. So in this year's data, we saw that 85% of the code bases had something that was more than 4 years old, and 91% had something where there was no development activity in the last 2 years. So the age of the component should be part of the vetting process. And one of the things that we know is that updates in the world of open source are communicated very differently than in the commercial software world. Because commercial software vendors know their customer, they're able to push update information, end of life statements, patches out to their customers. But because open source is freely downloadable, unless someone is actively engaged with the community and knows how that's going to be communicated, or a patch is going to be communicated, they're in a position where they could go for a very long time without receiving any updates. That is supported by the survey that we did last year, which said that only 28% of the respondents had one of their team members directly engage with the community, which means that only 28% of those respondents had a very clear visibility into the way that the community works and how it communicates its updates and patches. Now that's counterbalanced a little bit by 44% saying that they had some familiarity with the component or its community, but that level of engagement is really what powers any type of patch strategy that is going to keep things current. Similarly, vulnerability management is very different with open source. Now, I've got a list of our top vulnerabilities in here. And what is really shocking is that the item that's number one, CVE 2019-10744, well, it's also from last year. So there's something going on there, and I'll get into that in just a second. But the percentage of code bases with vulnerabilities, it's also not tracking in the way that we would expect 100% of the time. We have some organizations that are in the marketing tech, in the retail and e-commerce, and in the energy field, where the number of the percentage of vulnerabilities actually increased. We saw the world get a lot better with manufacturing and internet and mobile apps, where the percentage of vulnerabilities went down. But for those that were having an increase, this is a little bit of an alarm bell. And it's made a little bit more of an alarm bell because when we look at the top vulnerabilities and we compare them from 2020's data back to 2019's data, what we saw were 5 vulnerabilities that appeared in both lists and that didn't decrease. So we have vulnerability CVE 2019-10744. It was in 29% of the code bases that we looked at in both years. That's kind of bad, But if you look at CVE 2019-11-358, it went up by 15 percentage points from the 2019 report to this year's report. So that's something that you don't expect to happen. You expect that organizations are actually going to patch things in a relatively timely manner. Now, this year's code base, this year's report said that 84% of the code bases contained some form of vulnerability, and 60% contained high-risk vulnerabilities. Those are both alarming numbers that we see being similar trends from year to year. They do move around. And last year in our survey, we asked the question, well, what is your management practice around critical vulnerabilities? The respondents came back with, it takes more than 2 weeks to actually identify and patch a critical open source vulnerability for 75% of the organizations. That's not a quick cycle. That's not a, we're aware of exactly what's going on. But more importantly, when you ask the question of what's the impact to the delivery schedule, globally, 40% said that they had a negative impact to their delivery schedule to patch a critical open source vulnerability. And 52% in the US said yes to that question. One of the big reasons behind this is that where commercial software is able to issue a very targeted hotfix for whatever the issue might be, in an open source environment, it's far, far more common that the patch is the same thing as another release within the same version tree. So if you are 6 months behind on your patches or your updates, you're going to take not only the security update that you want, but also all of the functional changes, all the behavioral changes from whatever your starting point was, whatever version that is, to whatever you're upgrading to or updating to. And that presents a real problem in terms of how you test software. It's not a case of I can arbitrarily assume that it's going to work. I should be testing this to make sure that there are no behavioral changes, because those behavioral changes might be in the default configuration. And if you're using the default configuration, you could be blindsided by something that is a good idea, but destabilizes your application. Now, I mentioned those set of vulnerabilities, the ones that were like super critical. And if we kind of peel them back, what we find is that they all share the common attribute of being related to data sanitization. So all of the CVEs, 2019, 11.358, all the way through to my favorite 10.744 and a few others thrown in for good measure, they impact jQuery, Lodash, and Jackson data bind. In fact, CVE 2019-10.744 is a data bind issue, and it represents the 6th, if I remember correctly, 7th attempt to fix a prototype pollution issue. And the core commonality between these is that when presented with untyped data, so basically data that is, this is not a number, this is not string, this is not a type of object, but I'm going to let the library figure out that this actual piece of data is a string. I'm going to let the library figure out that it is a number. That type of indeterminate typing, that leads to the library to guess, and when it guesses wrong, bad things happen. In the case of the Jackson data bind, it's a remote code execution. In the case of some of the others that are up here, it's a cross-site scripting, it's elevation, it's prototype pollution, and in one instance, it is, well, you know, I have a guess, and my guess actually ended up being the code got stuck in a loop, and you ended up with excess CPU consumption. The ideal solution is, of course, to patch for these CVEs. The patches are available. It's not like you're waiting on something. But the real patch is to look at the architecture of the applications that you're creating and be explicit where you can. So use an explicit JSON schema. Use objects without prototypes so that you can now validate that the data is correct before the library touches it, not as a result of the library guessing what the data type is. And ultimately, you never want to be in a position where you're manipulating unknown data types, because that's how some of these vulnerabilities are expressed as, when I see nominally garbage data, I'm going to guess at it. Well, that garbage data should never have arrived in the first place. And by extension, you have a mitigation strategy in place. So what does all this mean to our teams? How do we know that we're on the right path or not? One thing that we can say is that the overall open source strategy, the overall processes and governance in place, they're not really keeping up with all of the usage that we're seeing. So last year we had 528 components on average per code base. 2 years ago, it was just shy of 300. We've gone up by 19% in the last year. I'd be willing to bet that that trend is probably going to continue. So if your open source governance strategy was designed more than 2 years ago, it was probably designed around a quantity of components that is far less than what is being used today. And that becomes really, really, really important when you look at the number of CVEs that are disclosed every year. Last year, there were an average of 48 new CVEs disclosed in the NVD every single day. So if you have an increasing quantity or a very large quantity of CVEs to contend with an increasing quantity of components, you have a stress point. Open source licensing, it's something that is manageable. Licenses very, very rarely change. It's not something where you have a new license or a change in license every single day, the way that you could have 48 more CVEs disclosed tomorrow. So you better solve the 48 CVEs that you had today, otherwise you are going to be behind. There really is no real excuse for why we see increases in open source license conflicts. This is a solvable problem, and a readily solvable problem at that. The security one's a little bit more complex. Now, I had people go and ask, well, 528, that seems like a really, really large number. If I go and look at the number of components that my teams are declaring, it's nowhere near 528. It's nowhere near 298. In fact, it's well under 100. So what's going on? Why are you seeing this as so different than what my experience is? And it really comes down to understanding the difference between a declared dependency and a transitive dependency. So the folks over at GitHub publish data under their Octoverse every year, and they actually looked into this problem very nicely. So today's world is built out of rich immersive experiences. People want that interactive application, and they want it to work on their device no matter how old that device is, no matter what operating system, no matter what application it might be loading within. So compatibility is a huge deal. For server-side applications, that's a semi-manageable thing. With Java, you're going to run it, but the number of transitive dependencies aren't really that big of a deal. Similarly for .NET, it's not that big of a deal. But because JavaScript is all about the compatibility side of the equation, they follow a paradigm that requires micro-packaging. So I know that on this environment, I need to load that component, which means that the framework choice is a big factor in the quantity of components. So in the Octoverse report, they found an average, or a median rather, of direct dependencies at 10, but 683 for transitive dependencies. So that's, I declare jQuery, but jQuery brings in a ton of stuff underneath. Or I declare that I'm using React, it brings in a ton of stuff underneath. So that means that the framework authors are forced to manage dependencies. The consumers have to manage dependencies. but the ultimate responsibility for what's in there falls within your team, because it's that whole corpus of stuff that you need to be paying attention to. Otherwise, you could get blindsided by a set of vulnerabilities. And in fact, this past year, we saw that the average number of vulnerabilities went up by 93%. That's a huge number. That's a big, big number. And it's all a function of awareness, because you cannot possibly patch code that you don't know you have, which means that you need to understand what your patch strategy for a particular piece of code looks like before you use the code, not after. Because once it's after, that process is going to be just a little bit different. And in the world of open source, part of the challenge is you need to know where your code came from. And you need to actively engage with the communities that are creating the code, because there isn't a single vendor known as open source. Some presentations that I do when I'm explaining the world of open source, I will go and kind of peel back OpenSSL a little bit. And the way that OpenSSL works is that there are a lot of forks. There are close to 7,000 forks right now of OpenSSL. Which fork you have, well, part of it is the distribution model. Did you get your OpenSSL as a result of having a Red Hat subscription or using Fedora or Debian? Are you getting your OpenSSL as a result of a fork of a fork? Maybe you have LibreSSL and you're going down that particular path. Do you have OpenSSL as a result of an API binding? Is your OpenSSL delivered to you by way of some form of meta repository like Docker Hub? All of these are distribution points, and there is in reality no single vendor known as open source, which means that the commercial security paradigms don't always work, and you can't always rely on them to be there. And so that's why we see things like the unpatched high severity vulnerabilities going up year over year, going from 40% to 60% in just 2 years. The awareness is key, but when it comes time to actually apply the patches, well, if we go back to the layout that I had at the beginning of the presentation where I said, here we have the free downloads and it's going straight into deployment, or we had the commercial procurement model, or I had the mature open source adoption model. If you look back to that slide, you'll notice that all of the vetting processes are gone. An update goes from the supplier into the private repository and the developer just uses it. There's no review of what the security practices were for a commercial component. There are no security reviews and license compliance checks and so forth when updating an open source component. It's essentially, I did the work up front. I'm going to trust that everything is good forevermore. That becomes a real problem when you start to look at how say open source projects evolve over time. And the same evolution actually happens in commercial software. It's just we don't see it because it's behind commercial walls. And that is, the humans who know the code are going to shift. The humans who are responsible for the direction of the code are going to shift. And if there's an error in how the testing is performed, well, you want to be able to catch it as early and often as you can. So why remove the security vetting process for updates when you don't need to? So that's one of the key takeaways that I would have from the OSSRA report. Make certain that you are reviewing the security of all of your updates, not just the code that you're bringing in at the point of adoption or the point of procurement, because there could be changes. They're very, very important scenarios to address. Now, Synopsys, we're committed to open source security. We have a bunch of different initiatives in place, one of which is free static analysis tooling for open source projects. So if you are working with an open source project and it is not having any benefit from a static analysis tool, it can be added to scan.coverity.com and you get the full benefit of our commercial tooling, our commercial Coverity tooling. And now, well, you can see the static analysis benefits. And this is tooling that is used by major projects like FreeBSD and the Linux kernel and Wireshark and Core Boot and OpenSSL and Zen. These are some of the thousands of active projects that we have in there. And in the last year, the number of defects that were identified and remediated that relate to null pointer dereferences and resource leaks and so forth, they're up on the slide. There are thousands of them. This is all contributing to the overall security of the open source software that we depend upon. So the question is, are you on the right path? Well, there was a little bit of an interesting event that happened on the 12th of May. It was an executive order issued by President Biden that basically said, hey, we've had a bunch of really high-profile incidents that impact the U.S., ranging from SolarWinds all the way through to the most recent Colonial Pipeline event. We need to get our act together. Unlike most executive orders that weigh in at maybe 2, 3, at the outside 4 pages, this one's 18 pages long. It gets into some very significant details around how you might approach securing a software development pipeline, where you know that the code itself is being built in ways that are secure. It gets into identifying the origin of the software. So what is the actual origin point, because the patch needs to match the origin. It gets into things like how incident response and transparency of information flow is going to be part of a modern cybersecurity world, where the testing that's performed on a piece of code needs to travel with the code as it's being used throughout its supply chain. That there are now bills of materials so that you know exactly what's in the commercial software and in the open source software that's being used. That there are deployments, and all of the deployment requirements are actually communicated to whoever's owning the deployment of that particular piece of software, so that they can know from looking at logs, things like it's working properly, it's going off the rails, what do we do? Things like zero trust networking, so that we can have proper authentication on the network and use minimum configurations and use least privilege. Yes, the executive order actually uses the phrase least privilege. There's a lot in here. There's not a set of real requirements yet. Executive orders are president telling heads of agencies that you need to go do something. But this serves as a pretty solid blueprint for what cybersecurity practices should look like. From my perspective, this is actually as impactful for cybersecurity, or at least has the potential to be as impactful to cybersecurity as GDPR and CCPA and other similar laws were for data privacy. So if you have not looked at this yet, I strongly encourage you to take a look at what this means for you and your organizations. Now, the policies that we have in our development streams, well, they really need to be looking at how software gets created and how it moves throughout its life cycle. So we all build applications and create artifacts. If we're building a containerized application, we're taking base images and we're merging them together with those artifacts to create a new container build image that is going to be deployed in a Kubernetes cluster, where users are going to go and do their thing. And there's going to be some set of compliance rules around how that application or how that container image is going to operate. That's our world. We've built these things into pipelines. But the problem is there are policy evaluation points that are kind of missing. So I have my libraries and my frameworks. I should be making certain that they're updating alongside the policies that I have. That when I go through my build process, whatever it looks like, that I only package it if it's met. The goal is to make certain that there's never any chance that something enters production that should never have entered production. So have a set of gates that protect things. So package the policy is met. I have a base image. I want to make certain that it's hardened. I want to make certain that it meets whatever my industry standards are. I can't go and take a DevOps world and say, I'm going to shift everything left onto a proverbial, mythical, magical developer who knows everything, and have the people who are creating, say, a Node.js app also be the people who are doing the image hardening. Two entirely independent skills. We need to make certain that there is an image hardening process that ensures that what's being put out there has a minimum attack surface. And that base image, because there's going to be CVEs that are disclosed out of band, well, it should only be pulled into a container build process if the policy still is met. And that the container build process also is assessing policy to make certain that it doesn't push it into that registry, because once it's in that registry, there could be a deployment configuration that is going to automatically update an application in the cluster. That would be a bad thing. So let's also have an admission policy on the cluster to make certain that the policy is appropriate for that particular application. And of course, you have the world where there's new external threats, so they always end up kind of needing to feed back. And so each of these policy points becomes places that you can go and evaluate what's working within your DevOps Mobius and build that information flow in, so that the security of what's being created is based off of whatever the policy is, and you don't end up with something that was accidentally deployed that has a bug that takes down major organizations, as we just so happened to see very recently when I'm recording it yesterday with Fastly and some very high-profile websites. So from an open source perspective, the question is, how do we do this in a responsible manner? So number one, we need to acknowledge that open source software powers modern innovations. End of story, full stop. And there needs to be a robust strategy. Otherwise, there will be ad hoc adoption. It is far too easy for someone to go and do an internet search, find a component, download it, and bring it into an organization. Without having that robust strategy, you're never going to know exactly what's being run. So you need to know what the actual set of criteria are, and train those development and operations teams to identify when there is a critical component being used. Critical components are fundamentally things that without that component, your business doesn't function the way that it's supposed to. So for example, Kubernetes, or whatever your management plane is on top of Kubernetes, whatever you're using for your container runtime. Those are all examples. If you are a Java shop, where am I getting my components from? Make certain that your POMs are all set up properly. Recognize that open source is managed differently from commercial software, because once you accept that, you can start to build threat models that are specific to that usage, that don't rely on, well, I need to have a data feed for my commercial software. Modern innovation is all based off of open source. And the governance really starts with the developers, because the developers are the ones who are making the decisions, not someone in legal, not someone in a procurement team. So you need to train all the developers to understand the implications of the licenses that they're adopting. This is not as simple as saying, oh, MIT and Apache, those are okay, I can work with those. Or GPL is okay, I can work with that. Because you get into nuances between different license types that you don't necessarily expect. So have your developers understand the implications, because they might choose a different component that is equally serviceable, but has a different license if they know the requirements. The patch strategy has to include security reviews for open source components, and it needs to be defined before the component is brought in, because if it isn't defined, then one of the important things that it gets lost is where the component came from, because that's where the patch needs to come from. If you've got thousands of different forks of a component, you could have slightly different versions in each of those 1,000 forks. In my house, I assert that there are at least a dozen different versions of OpenSSL, none of which will be patched the same way. Which means that for me, an inventory of all software for open source usage, not just the source code, is key. This whole OSSRA report is based on the analysis of commercial applications, which means that those commercial applications had open source in them in the first place. So take a look at the binaries that are coming in. take a look at the commercial software that's coming in, take a look at the source code. Each of those has a slightly different management paradigm, but the governance strategy all starts back with the developers. And those developers and operations teams, they really, really, really need to engage with the open source communities that are creating what they're using. Open source is community-led and vendor-supported, not the other way around. The updates, design decisions, architectural decisions, they all occur at the community level and not with product managers. Expecting that an open source community will go and take a GitHub issue that says, I need feature X and implement it is a pretty low success rate. The community, however, will very cheerfully take the suggestion along with a piece of code that is reasonably well defined and potentially merge it in. That level of engagement allows teams to actually start to drive the direction of that open source project and its community, and creates more of a shared sense of ownership, greater engagement, and all of that leads to an enhanced set of collaboration skills that are inherent with the distributed development teams that are common in the world of open source. So there are a lot of benefits to teams, even who are explicitly creating proprietary software, to actually engage with open source communities because of that collaborative, shared ownership, shared design paradigms that are key to open source communities. So I know that this webinar is being recorded. If you need to contact anyone on our sales side, they'll happily talk your ear off. If you have any questions about the content that was provided today and you're not doing it live with us, you can reach out to me. I'm at Tim in Tech, or you can reach out at our group's Twitter. We're at SW_integrity. Thank you very much. I'm Tim, and we have about 10, 12 minutes for questions, and I'm going to take the slides down and go over to the other console. And if there are any questions, I'm happy to take them.
Fantastic. That was really, really great, Tim. Thank you so much. And we do have some questions here. I'm going to jump into this one because I think the executive order from President Biden that you mentioned is a pretty big topic of conversation throughout the industry. So what can technology buyers and suppliers do today to prepare for the changes that will result from that EO?
So it's a little bit early to know exactly what the changes from the EO will be. By, let's call it the middle of July, we'll have a little bit greater clarity. And that's because one of the directives is NIST go figure some things out and then report back some guidelines. And so their deadline to do that then. But for today, there are a couple of really important things that anyone, particularly in the security leadership and the development leadership within an organization, can do. And that's to understand how their development is working and how they're communicating updates and information internally, so they can start to prepare for things like mandates around transparency of log, mandates around transparency in the security testing that's being performed, mandates around understanding the origin of code. What the actual format that the requirements will take, that's still TBD, but the process is something that can be done today. Understand how often your threat models change. Do they incorporate an understanding of the origin of the code that you have? And so effectively taking that, if I had to comply with this to the letter, am I prepared to do so? And start your planning at that level.
Gotcha. Yeah, this is like the prep period. Everybody's getting their ducks in a row.
Exactly.
Okay.
Exactly.
So let's see, what else do we have here? Who should be involved in defining our open source governance strategy?
That's a good one. That's a really good one. So for me, and I've said this from stage for a rather long time, if you're on the development side of the house, if you're on the operations side of the house, don't be afraid of going and talking to your lawyers. So their job is to understand the risks to the company. Your job is to implement and deploy the software that is going to power the company. They specialize in one thing, you specialize in something else. By meeting in the middle and asking reasonable questions, you're now in a position to understand the things that the company considers particularly risky and make certain that whatever your development practices or your deployment practices don't run afoul of that set of risk elements. And you can start to bake in things that are more threat model-y as well. That's where it becomes a combination of the operations team, the development team, and the legal team. Now, the security people end up somewhere in the middle. But if everyone gets together and says, look, we want to do the right things, when the inevitable incident happens that you need to respond to, at least the legal and the security teams know that the developers and the ops folks are in the good guy club, that their hearts are in the right place. They're trying to do the right things, and they're no longer just a name in Outlook where, wait a minute, I need to be shouty at this person because of X. So transparency of information, transparency of process, make friends between the teams.
Okay. Yeah, and I mean that makes sense as a general principle too, right? You're always trying to align your development and engineering activities with the larger business goals and strategies of the organization. So it's just
Yeah,
a similar.
it's something that I've done in various jobs for years. I have no problem going inviting the folks in the legal team out to lunch and just kind of like, they need to eat too. We can sit in the cafeteria together. We can start to know each other as people and have a more natural conversation than what you're going to get when you're dealing with an incident and you've got forensics people trying to crawl around and say, gee whiz, where's the logs for that? You want to get ahead of that sort of thing.
Right, and kind of build that trust before something terrible happens.
Yeah, okay. Exactly.
All right, so this one, here's a good one that just came in. What are the essential components of open source strategy?
So there are a couple. So the first is understanding the set of obligations that you have around the open source components that you're using. Because you might have something that is really, really, really easy to comply with, like you must keep my copyright with the files and tell everybody that this is copyright Tim Mackey. That's something that's really easy to comply with. And if you miss it, you could be in trouble later on. Some of the other obligations can be a little bit harder to comply with, like I need to know exactly what changed in the code, or I need all of the source code. Those have a greater effort associated with them, but just know what the license obligations are. The next one is know where the code came from so that you can get your patch from there, because either that code is not being patched, in which case that's a problem, or it's being patched at whatever interval and the patches are being communicated in this way. So you should know what the interval is and what this way is. Then as the code, as that component comes into the organization, you can document that, well, we need to make certain that we're checking this way, or build some automation around checking that there's an update. And then from there, the rest of the patch management process flows naturally. But those two elements, knowing where the code came from and how to update it, as well as knowing the license, those are the bare minimums.
Okay. Awesome. All right, let's see. Oh, here's a good one. Do I only need to worry about open source risks if the software is going to be distributed?
So yes, if that's a license risk. No for security risks. You still need to worry about the security risks, even if you're just using it inside your company. That there are fundamentally three types of risk, when you start dealing with open source. There's the license side of the equation, there's the security side of the equation, and then there's the age. You can solve each of them with slightly different techniques, but from a distribution perspective, license applies. If you're just using it internally, very, very few licenses apply. And the one that comes to mind most is if you're using it internally to create a website for someone, and there's going to be humans accessing it, then there are licenses that apply to that. So you just need to be a little bit careful about the distribution side of things, which is why reviewing licenses are so important.
Right. All right. So I think we've got time for one, maybe two more. So let's see. What is the downside of using open source that hasn't seen any recent development activity? And I guess a follow-on question to that would be, and if you want to use something like that, should you review it? What should you do with it?
So that's a really good question, and it's one that is harder to answer in the abstract. So there are components that are easily, quote, done. And when they're done, there's not necessarily any need to update them because they might be something that's very, very simple, like a regex for how an email address is constructed. You only really need one of those. A bunch of people have created them, but you only really need one of those. And that component is probably going to fall into the done category pretty quickly. And the fact that it's old doesn't really matter all that much. When you start dealing with things that are more complex, things that are actually critical to your environment, the probability that you can now claim doneness with a component is going to be time variant. So what was done 2 years ago, according to the best practices of 2 years ago, might be hugely risky today. One of the best examples of that, look at the vulnerability that has the title of Dirty Cow. It was a dirty copy on write vulnerability in the Linux kernel from a few years ago. Look at Linus's comment on the patch. At the bottom, he basically says, look, this is something we've known about for the better part of 10 years. We tried to fix it once, it didn't work out so well, so we reverted all the patches. What's changed is that 10 years ago, we didn't have highly concurrent multi-threaded processors, multi-core processors. Today we do. So the world changed, the code stayed the same, and the risks of whatever were deferred defects, they became a huge issue.
Okay.
So do a little bit of diligence on the components and making certain that the complexity of what's being deployed is factored in.
Understood. All right. Well, I think that is all we have time for. If we did not get to your question just now, never fear. We're going to round up all these questions and send them over to Tim, and he will be sure to follow up afterwards offline.
Yep, will do. Thank you, Sharon.
You got it. Just a reminder to the audience that this session has been recorded. So if you missed any or all of it, you can absolutely watch it again. We'll be sending an email with instructions for how to access this webinar on demand, or you can visit us at devops.com/webinars, and it will be there for you also. Again, just a reminder, we have a bunch of handouts there that you can access and download and read afterwards as well. So make sure that you're grabbing those too. And I'm going to jump right in here, and we're going to draw the winners for our 4 $25 Amazon gift cards. All right, so our first winner today is Jan H. Congratulations to Jan. Our second winner is Clay N. Clay, congratulations to you. Logan A. is our next winner. And our fourth winner is Paul C. Congratulations to all our Amazon winners. We will be sending an email to you with instructions for how to claim your gift card. If you don't see the email come through, make sure and check your spam folder. All right, well, that does it for me. I want to thank Tim so much for his time. And thank you again to the audience for spending your time here with us. We hope to see you again soon at another DevOps.com webinar. I'm Sharon Florentine, signing off.